So I thought, it's only a matter of, years before everyone goes active, right? This was back in, would have been 72 or something like that, 1972 or 3 or something. And so that didn't happen. Well, except in Pro Audio it happened.
Welcome to StereoNET. We're here in the StereoNET Hi-Fi and AV show in Melbourne, and I'm fortunate enough to be joined here in the studio with Kim Ryrie, the co-founder of DEQX. Welcome, Kim. It's a pleasure to have you here in the StereoNET Hi-Fi and AV show.
Thanks for having me.
Why don't we begin by explaining what DEQX products do and how they're typically used in hi-fi and pro audio markets.
Well, the name DEQX stands for Digital EQ and Crossover. So what we aim at is to remove the errors in loudspeakers, and that means we've got to process the audio going to the loudspeaker to compensate the errors that we know the loudspeaker is going to introduce. So part of the DEQX process, if you want to do it, is to measure your speaker with a calibrated microphone that we supply. That sends that measurement to our cloud. The cloud analyzes what's called the impulse response of the speaker, and that information contains the frequency response, which most people know about. Frequency response, it needs to be, or frequencies need to play at a accurate level. But what also happens with speakers is that they delay some frequencies more than others. So typically the delay through mid-range frequencies is like a millisecond or 2 milliseconds, and sound travels a foot in a millisecond, for example, for those people that remember feet like me. So what we do is we slow down all the audio so that the slow frequencies can catch up, and then we put all the audio back together again. So it's a very computationally intensive process, but you can't do that in the analog domain. You have to use digital signal processing to do it. It's called convolution impulse response calibration, in effect. So that's one aspect of what we can do. So we can do that to a passive speaker, a normal hi-fi speaker. So that'll correct some aspects of what that speaker's doing. And for a particular model of speaker, you can that will carry to other speakers of the same model. The errors tend to be very similar between the same speaker model. But what we're demonstrating at the show is an active setup, which is pro audio. Speakers are all active. That means there's a separate amplifier for each driver, separate as an amp for the tweeters, another one for the mid-range driver, another amp for the bass driver, and the subwoofer if you want one. So that's the ideal situation, because that lets you, first of all, it lets you choose the amplifier that's good for a tweeter, and another amplifier that's best for mid-range, another amplifier that's best for bass. But then you do the crossovers filters in front of the amplifiers at pre-amplifier level, which is what our box does. So our box is effectively a preamp. It's also a streamer. We're streaming Roon, we're streaming Tidal, Q-Buzz, we've got Roon, that sort of stuff. So it packs all of that into one box. So one of the models gives you up to 4 outputs, so that you can do your own active speaker design if you want. You can make your own speaker and it'll sound fantastic, because it's a completely integrated solution. So we have all the measurement software integrated with our system. And so it's good. It's good for. So we have a lot of sort of high-end DIY people. We have a lot of speaker manufacturers at the high end using it, or planning to use it. That's the idea. So, and sorry, I should have mentioned that we do linear phase crossovers between, say, the tweeter and the mid-range driver and the mid-range driver to the bass driver. That means that there's virtually no crossover distortion when you transition from one driver to the next to the next. So it's very difficult to do that without introducing errors unless you're using linear phase crossovers, unless all the timing is compensated.
Okay. As I understand, DEQX is not your first successful product. You also invented the Fairlight CMI, which stands for the Computer Musical Instrument, back in the early 70s.
Back in the day.
Back in the day, with feet. It was adopted and shot into the spotlight by use from Kate Bush and Peter Gabriel, amongst many others. Did that early work lead you naturally into what DEQX as a company does today?
Well, yes, it did, in the sense that, well, before Fairlight, I had a band and we used Altec Voice of the Theatre speakers. Some people watching this will know the old A7 Voice of the Theatres, and that had a horn. And I used to blow the horn up at least once a week. The tweeter, the diaphragm would blow up in the horn. And I'd started an electronics magazine before that called Electronics Today. That became Electronics Today International, where we did DIY amplifiers. So I had these little 100-watt amplifier modules lying around. I thought, I could try making the Altec go active, and I wonder if that had stopped blowing up the tweeter, the horn, I should say. So I built a little active crossover. It was just 24 dB per octave, which is what most pro audio speakers use these days, and which is like twice the slope, twice the protection of the tweeter from a 12 dB per octave, which is what Altec's passive crossover did. So we didn't blow up any more tweeters after that. But more importantly, it just sounded so much cleaner because we weren't distressing the horn all the time, because there wasn't so much bass energy getting to the horn. We weren't hearing so much rubbish coming from the woofer because it wasn't able to get so high in frequency out of the woofer. So I thought, it's only a matter of years before everyone goes active, right? This was back in, would have been 72 or something like that, 1972 or 3 or something, and so that didn't happen. Well, except in pro audio, it happened. So then I started Fairlight because as part of the magazine, the Moog synthesizer came up, and I wanted one, and I couldn't work out how to get a Moog synthesizer. So I convinced everyone at the magazine, where we designed the DIY products, how about we do a build-it-yourself synthesizer, right? And they all go, oh my God, the boss's son's gone nuts. So I talked them into doing that. That took 10 months to publish all the modules in an analog synth, like a Moog synth. At the end of that, I was frustrated because I couldn't make natural sounds. It sounded like a Moog, but and there were thousands built around the world because we had an English edition and a French edition by then, I contacted her, and this was when the microprocessor had just come out, the first Motorola 6800 microprocessor. And I rang up a schoolmate. We used to build stuff at school together, called Peter Vogel. And I said, what are you doing? He said, not much. What are you doing? I said, not much, but I want to build the world's greatest synthesizer. Do you want to help? He was a much better designer than me electronically. And he said, well, how's that going to work? And I said, we're just going to get all these oscillators and filters and microprocessors, and it'll just work, and that's that's how we'll make a natural sound. Anyway, I convinced him to do it. We had my grandmother's basement on the waterfront of Sydney Harbour, where Lawrence Hargrave used to design his aeroplanes. Same basement, actually. And so we started that, and my idea was ridiculous. It was never going to work, but someone introduced us to a guy called Tony First, who'd done a microprocessor, start of a digital synthesizer, and he was having trouble finishing this project, but he designed a microprocessor with a light pen. This was before the mouse had been invented, and we said, great, can we take over your microprocessor design, and which actually at the time was the first parallel microprocessor design ever in the world. Tony had designed, unbelievable. And he said, sure, take it away, because I'm sick of this project. You take it over. You've got to design, you've got to deliver one of these to the Canberra School of Music because they've ordered one. And so I said, sure, we'll do that. Anyway, it took us a couple of years. We worked on that design. And then I realised it sounded horrible. It just sounded synthetic, and you could create waveforms out of harmonics. You drew on the screen with a light pen, you wind up all these phases: first harmonic, second harmonic, third harmonic, and then we animated them, and it sounded interesting, but it still sounded electronic. And then the memory chip came out, a 16 kilobit memory chip. Right? Yep. I said, hey, Peter, we could put 8 of these together, and that's 16 kilobytes of memory. We could sample an actual acoustic sound into that. Peter's going, yeah, okay, let's do that. So Peter ran off and designed an A to D in about 2 days, and we had that working. And then because we were already manipulating the memory, we were able to make the first sampled sound playing on a keyboard. So the Fairlight CMI became the first sampler where you could play natural sounds, and then we added to that sequencing, so it became the first sequencer. In effect, you could play on the keyboard, it recorded what you did. And then we were building these in Sydney, and we had to do everything. There was you couldn't even buy monitors and keyboards. Like the alphanumeric keyboard, I had to get the key tops engraved to make a keyboard. And so that was called the CMI, Computer Musical Instrument, and they cost $25,000 US back in 1980 when we brought it out. So people like Peter Gabriel, Kate Bush, Stevie Wonder could afford them because they had lots of money. And that's how that Fairlight started, and they sold a lot of those.
Wow.
It was a crazy product.
Yeah.
And then, by the way, then we did post-production with Fairlight, and we did the first digital audio workstation, first 24-track digital audio workstation. And then nowadays, Fairlight, all Fairlight's IP was bought by Blackmagic, which is a Melbourne-based company. And you can download the latest Fairlight software for free, for starters, from the Blackmagic website. They've done a fantastic job with it, yeah. And yeah.
Okay. So with 20 years under DEQX guys and another decade in early EQ and DSP technology, where was the focus for DEQX, and how has that focus moved or changed over the 3 decades?
Yeah, well, so at Fairlight, of course, we were doing the first digital signal processing in Pro Audio, actually, funnily enough. And so we were using the first DSPs. And but later on in Fairlight's history, I got a call from one of our employees, a guy called Brian Conley, who'd started a company called Lake DSP, and he wanted to know if I could help them with their headphone technology. It was out of headphone technology. And they were using long convolution to simulate binaural ear effects, so that sounds like the sound was coming outside of your head if you were wearing headphones. So I worked with Brian for about a year to help them do that. That's now called Dolby headphones. Dolby ended up buying that company. But I said to Brian, why don't you use this FIR stuff to do loudspeaker correction, because this is exactly what loudspeakers need. He said, oh no, it's all too hard. We've tried it. Anyway, it does work, but it's a lot of work, and we're focused on the headphones. Why don't you do it? And so that's how we started DEQX. That was in '97 actually. And so it was just, originally we were going to use some of their technology. We ended up doing our own for that. I started DEQX with Paul Glendenning, who was the main engineer at the start of that project.
And you mentioned FIR.
Yeah, so finite impulse response is FIR. This is the thing that enables you to slow down the on-time frequencies so that the delayed frequencies can catch up. So it's a very complicated arithmetic that I fortunately don't do. We've got a PhD called Matt Flax, Dr. Matt, who does all our new stuff in the new products. And we've got 3 other programmers as well that work with Matt. We've been a couple of years developing new hardware. We've been delayed because a couple of the earlier designs of the new generation hardware, we had to stop, the AKM DAC factory burnt down, and we had to change that design. And then we found the processor we'd chosen wasn't quite up to it, and we had to go to another one. So it's just been a long process, but we're pretty happy with it now.
So DEQX is world renowned for cutting edge and DSP. You're launching arguably the biggest evolution in the platform's history this weekend, with the vast improvement in computing power, software platforms and open source software today. How does that play, or how did it play a role in this new range?
Well, so the main difference between the legacy DEQX products, they were fairly hard to set up. You had to have a Windows computer, or we had about 1 million lines of code we'd written over the years under Windows, and there was a 160-page manual how to do it, so it wasn't a trivial project. So with the new thing, we've gotten rid of we're not using DSP chips anymore. They were 32 bits, they were 400 megahertz. We've moved to the new 64-bit ARM processors. They were in effect, it's a 10 times more processing power than we had with the original legacy DEQX models. And at the same time, we've taken all the software off Windows. We've had to rewrite most of it, put that into the cloud. So now you can run you can set up the product just using a browser on an iPad or any computer, basically. So it just and then at the moment we're just automating most of the software. So you don't need the 160-page manual. It's much easier to work. And we've done it, and because all the A to Ds and D to As are redesigned, that's we're getting close to the 120 dB distortion mark, which is very, very low distortion. The trick when you're using so much digital processing, the hard bit in a way is just getting the digital noise out of the system, and that actually has taken us quite a few years to get right. The early DEQX products were not spectacularly good at that. The last round were pretty good, but this new one is about 10 dB better than the last one.
Okay, that leads into the next question. Yeah. So with your technological changes, can you elaborate on how those technology advances has made some product capabilities a reality, but on the flip side, has that advancement in technology exposed other audio reproduction areas where either more R&D or exploration is required to improve or resolve? Yeah,
so just about anything makes a change in audio, in high-end audio. So the sort of research that we're still doing is room calibration as well. So and to make that simple to do at high resolution. We're trying to make it cheaper so that we can offer other speaker manufacturers an inexpensive way of implementing the technology. The loudspeaker is the weak link to high-end audio. It's things like 192K sample rates, and that is just completely academic. When you come to a loudspeaker that is just going to double decimate all the measured characteristics of all the trouble you've gone to, with the media resolution. So the focus really needs to be I'm not saying everything has some effect on audio. You know, obviously you need great amplifiers, you need great everything, but the speaker is where it really is difficult to get it right. There's just so many electromechanical catastrophes going on that you've got to deal with, you know.
So where has DEQX been most successful in solving audio issues? Is it room configuration, acoustic room treatments, optimising loudspeaker response, or other areas? Yeah. Where do you see that? And how does your current product line help end users with these areas?
So, well, we don't really have much to do with room furnishings or anything like that. We basically assume that the room is a disaster when you go in, because most people's rooms are. So there are other people that will do room treatments that will be good, that will be effective. But in our case, we just measure what's going wrong and then we try to compensate for that. But our key difference, because there's other programs, as you know, that do room correction, our key issue though is with the speaker, the native speaker performance. So we actually can do things to a speaker performance that its designers couldn't do because they just weren't allowed. They were told, you've got two wires, you know, plugged into the back of a box coming from an amplifier, make it sound as good as you can, right? Well, that's hard. That is really hard. And it's why the best speakers can cost, you know, tens and tens of thousands of dollars to get to minimise the errors that happen in this electromechanical world. So, you know, our approach is our party trick is to get a, you know, $100 speaker, which sounds horrific, and then measure it and correct it, and suddenly it sounds, you know, like $1,000 speaker. It doesn't sound like a $10,000, but it sounds a lot better. So what impulse response correction can do is it can work with very low cost equipment if you can make it cheap enough to implement. Or with our products that we're showing at the show, that's our high-end reference quality stuff. And it's, you know, it's expensive because it's the top of the line gear, and then, you know, over the years we'll be able to scale it back in cost, and also introduce surround versions, you know, for home theatre and so on. Yeah.
That leads to the next question. So, your product family, you know, focuses realistically on stereo or 2-channel. As an industry, we're seeing more tech advancements using DSP and multi-channel applications. Now, in particular, Dolby Atmos soundtracks and Atmos or spatial audio. Are multi-channel applications on your future roadmap?
Yeah, absolutely. Yeah. So, you know, I love stereo. I love great stereo, but it's on the roadmap that we'll do versions. And a lot of people use DEQX now in their home theatre systems. You can just set it up to correct the two main channels, and still have it in a surround scenario. So that's not a problem. By the way, the other issue with DEQX is because we're correcting the phase coherence, you tend to get a much tighter phantom image in the centre. A lot of people that have DEXs, especially if they go active with DEQX, they just throw out their centre speakers. They don't want them anymore because it just creates such a tight centre phantom image. Yeah.
So finally, can you give us a brief overview of the new DEQX range that you're showing this weekend and the applications for each product?
Yeah. So there's the one we got at the show is the Pre-8, and it's the one that is for active systems. So we're showing an active 4-way speaker. A lot of people would get the Pre-8 even though they're only driving traditional passive speakers. They can then add a subwoofer to their traditional speakers, and the Pre-8 lets them in the future upgrade their system to an active system. They might want to get inside, hack out the passive crossover, add some amplifiers and do a DIY upgrade, or they might want to build a fully active system themselves, which is fun to do. The Pre-4 just has 4 outputs. So 2 outputs for the main passive speakers, plus 2 for optional subwoofers. So you can add 1 or 2 subwoofers. The front going in is the same of all products. We've got a Dynavector phono preamp that was designed for us by Dynavector, so that's included in all models actually. It's for a high output moving coil or a moving magnet, phono. There's a couple of other analog inputs. There's lots of digital inputs, TOS-Link and AES EBU and USB audio. And there's one other model called the LS200, which has an amplifier in it, and that's for probably, not so much the audiophile person, but someone who just wants to plug speakers in and play, and it's got all the same streaming, same input capability. It still sounds great, obviously.
But it wants to equalise great music, great sound at the end.
Yeah. So, well, I suppose I'd ask, here's a question. If you're a loudspeaker manufacturer or a preamp manufacturer, would you consider implementing this sort of technology? Because we're hoping to help, other manufacturers, incorporate this sort of technology. We're working on, one of our R&D projects is working on FPGA chips that are very cheap to implement at very low end speakers. And so there's only just one measurement and there,
Sure.
So.
Okay. Kim, on behalf of StereoNET, congratulations on bringing the new and highly anticipated range to the market, and thank you for your excellent insight into the DEQX brand today. If viewers have any need for seeking out more information about DEQX products, where can they go for that?
DEQX.com. That's it. Thank you.